final exam, it was just missed so much, and it's not that hard. We really should know how to do this at this point, okay? So everybody, I mean, you should have learned it in secondary too, for sure, but you should be able to do this. So we have all this stuff being raised to the -1/2 power, right? So first of all, properties of exponents. Do you guys understand that this is a property of exponent problem? Okay, so we have our little song. When you multiply you, when you divide then you, raise a power to a power and you. Right, okay, good. Alright, so all this stuff is being raised to the -1/2 power. So it's 4 being raised to the -1/2. So we have 4 to the -1/2 power. Alright, so then we have x, raising a power to a power and you. Do you understand how this is x to the -2 power being raised to another -1/2 power? Do you understand why it's power to a power? Yes or no?
Yeah.
Okay, so -2 times by -1/2. So let's say you didn't know how to do it by hand. Do it in your calculator. What do you get? If you didn't know how to do it, you can do it in your calculator. Don't just look at me. You do it. Okay, we get x to the first power. Very good. Raise a power to a power and you multiply. So 4 times -1/2. Everybody, if you don't know how to do that by hand, do it in your calculator. -2. Okay. How many of you were at least able to get that far? Not a soul. Oh, this group. This group. Okay, good. Yikes, people. All right, so then we know if we have a negative exponent, we have to flip it over a fraction. So I'm going to draw my line. This needs to be flipped down here. So it's going to be 4 to the +1/2. This needs to be flipped over a fraction. It's going to be y to the +2.
Question.
Yes.
Why wouldn't you just take the exponent down into the number itself?
Yeah, why couldn't you just simplify that?
You could. So if you do it that way, that's fine. We'll all you'll get the same answer. Okay? So then from there, on top, we have an x to the first left, which is x, right?
Yeah.
And on bottom, we have 4 to the 1/2 power, and then we have y to the second power. Now, if you have a number raised to something, you can simplify it. So type it in. 4 raised to the 1 divided by 2. Everybody should type it in, not look at me. Not 1/2. 2. So what's that? So we have an x on top, a 2 on bottom, y squared. So this would be our final answer. So, is that the same answer that you got?
What if we gave it a valiant effort?
Not good enough. Sorry, buddy. Nice try, though. Okay. Did you have questions on how to do this problem? Yes or no? Was it that bad? Okay. So would you be able to do something like that tomorrow? Okay.
Why did those two...
Question. So you guys, I just had somebody ask me this. Why did these go down and x didn't? Did x have a negative exponent? No. So that's why it stayed. Good question. Any others? Loved it. Okay, moving on to what we're learning today. So what we're learning today. Okay, so today we're doing, I didn't even label it. So today is 5-3. We're going to be doing families of functions. If you were in Mrs. Watcott's class, you've already learned this. We've learned different things. So, first of all, there are sets of functions called families. So, which each function is a transformation of a special function called a parent function. So, today we're going to be, for the most part, dealing with linear functions. Linear functions are a form of a family of functions. So, each linear function is a transformation from the function y equals x. So, we are dealing with lines today. We know that lines have the form y equals mx plus b. But the parent function of a line means the non-shifted, most basic function. That would be y equals x. So once again, the function y equals x is the parent function for linear functions, which means it's the most basic non-shifted function. So once again, a parent function is the simplest form of a function. So I'm not going to read all this, I'm just going to say it in words. So everybody, a parent function is the most basic non-shifted function. So for example, for quadratics, the parent function would be y equals x squared. Does everybody understand how that's the basic non-shifted function? It's a parabola that's been non-shifted. Y equals x squared. So do you understand that that would be the parent function? Okay, so then the parent function for a line means non-shifted. It's just right at the origin, and it has a slope of 1. So the parent function of a line is y equals x. The parent function for like A square root function would be y equals the square root of x. So do you understand how, like, the parent functions are the basic non-shifted functions? Is everybody good with that? So that's all we need to get out of this slide. So once we have the parent function, guys, any other function that comes from those, any function of those forms, will just be a transformation of the parent function. So remember, we can take a function, we can shift it left and right, we can shift it up and down. Am I right? Everybody remembers this, right? We can shift it left and right, we can shift it up and down. Remember, if x is being added, if there's something being added with x on the inside of the parentheses, it's our shift left and right, right? Everybody, do you remember this? So it's our shift left and right. Do we go the same or the opposite?
Opposite.
We always go the opposite. Very good. Way to remember that. And then anything added on the outside of our function, such as f of x plus or minus h. So that's our shift up and down. Anything added on the outside is our shift up and down. Should we go opposite or stay the same? Same. Good. So we're just going to be doing this today with lines. So everybody look at this. So once again, if it's added on the outside to our function, if it's f of x plus k, that k is being added on the outside of f of x. That's our shift up and down. It stays the same, like you just said. So for example, this is f of x. This red line is f of x. If we shift it plus k, we're literally taking the function, shifting it up. That amount, right? If we take f of x and we subtract k, we're literally taking that function and shifting it down that amount. Is everybody comfortable with that? Yes or no? Okay. Then we just talked about how if you add something on the inside of your function with x, that's your shift. Left and right, you always go the opposite. So look up here. This is f of x. This red thing's f of x. Now look, this is f of x plus h. Now notice, because it's plus h, we shifted back, right? We always go the opposite. This is f of x minus h. Because it's minus, we always go the opposite. We shifted it forward. Is everybody comfortable so far? This is not new to us. Okay, so in this example right here, everybody look, it says, how are the functions y equals x and y equals x minus 2 related? And how are the graphs related? So this is how I would do it. I would make a table of values. Let's look at the table of values here. So here's our x values. Here's our y equals x values. And here's our y equals x minus 2. Now look, here's y equals x. These are the y values for y equals x. Now look, we shifted that function down 2, right? So look, all of our y values are shifted down 2. We're subtracting 2 off of each of those. So negative 2 minus 2 is negative. Negative 1 minus 2 is, and 0 minus 2 is negative 2. So do you see how we're taking this parent function and shifting it down 2? We're just taking our y values and subtracting off 2. Look at the functions. Here's the function y equals x. Well, if we're looking at the function y equals x minus 2, we take that function and literally just shift it down 2. Does everybody see how it works here? All right. Same thing with the parabola, guys. We won't get into too much depth here. It says, what's the graph of y equals x squared minus 1 translated up 5 units? So here's x squared minus 1, and we're translating it up 5 units. So we're literally taking all our y values and translating them up 5 units. So look, there's that y value. We're now taking it instead of, does everybody understand why I'm adding 5? Well, I mean, I'm telling you, translate it up 5 units. So we're going to add 5. So x squared, and then let's add those up. What's negative 1 plus 5?
4.
X squared plus 4. So we're good there. So we're translating it up 5 units. So up 1, 2, 3, 4, 5. We take all our y values, translate them up 5. So this is a y value. We're translating it up 1, 2, 3, 4, 5, and so on. Do you see how this works? You take the same function and shift it up 5 units. Okay. Oh, so look, so once again, I mean, the y values are all shifted up 5 units. 3 plus 5 is 8, 0 plus 5 is 5, and so on. Okay, so let's answer this question. Now it's just to practicing for a minute. It says, how are the functions y equals 2x and y equals 2x minus 3 related? How are their graphs related? So we have y equals 2x compared to y equals 2x minus 3. How are they related? What are we doing with y equals 2x? Very good. Same shape. It's a line, right? Y equals 2x. What are we doing with the line? Shifting it down 3. Questions on that? So we're shifting it down 3. And it says, how are the graphs related? Well, for the exact same graph, it's just shifted down 3 units, right? So all our y values are 3 less. Does that make sense? So I mean, it just depends on how you want to say it. So I'll just say y values are 3 less in y equals 2x minus 3. Do they have the same slope and everything? Yes. Okay. So we're literally taking y equals 2x, shifting it down 3 units. Okay, next question is, what is the graph of y equals 3x translated up 2 units? You tell me. 3x plus 2. It's pretty simple. Nothing tricky here. Any questions? Now, why isn't this shifting our line left and right? Good, it's not connected in with the x. So it's being added on the outside of our function, right? Outside of x. Very good. Okay, so next question here. It says, for the function y equals x minus 4 squared, identify the horizontal translation. So is this a shift left or right? Or is it a shift up and down? It's our shift left and right. Is it being added with x or on the outside? With x. Isn't that our shift left and right, guys? So we're shifting it left and right, and we always go the opposite. So we're taking y equals x squared and shifting it right 4. So we're going right 4. So then we have learned, so we know the parent function is f of x is equal to x squared. So we have x squared was right here, we shifted it right 4. Now from there, we know how to graph quadratics, right? You go over 1, so that's our vertex, you go over 1 up, 1 over 1 up, nope, over 1 up. Guys, 1, 3, 5, guys, come on. Over 1 up, over 1 up, 5. So we do that on both sides. Over 1 up, over 1 up, over 1 up, 5. So we can draw in our parabola. Okay, questions? Okay, so a couple more that I'm going to let you work. It says, the graph of the function f of x is shown at the right. Make a table of values for f of x and f of x plus 3. So are we shifting this left and right? Okay, apparently you guys don't need my lesson, so everybody do the front of the listen up. So we can take a function from the parent function, and we can shift it. We can take a function from the parent function, for example, a quadratic. So my hands are modeling a quadratic. And we can take a quadratic, and we can shift it left and right. We can shift the quadratic up and down, right? Well, also, there's other things we can do with this quadratic. So what you can do is you can reflect it. So you can take the quadratic and reflect it. You can take a function and reflect it. So you can reflect it over the y-axis. So here's our y-axis. You can take it and reflect it over the y-axis. You could also take that function and reflect it over the x-axis. Now how you know if it's a reflection over the y-axis is, so a reflection over the y-axis is if you have f of negative x. So instead of an x, if you plug in negative x into your function, whatever you get out, that would be a reflection over the y-axis. So let me write that down. So notice, when we reflect over the y-axis, all of our our y values stay the same. So it's still up at this y value of 4. It's still up at 4. It's still up at 1. It's still up at 1. But the x values are just the opposite. So notice my x values are just the opposite. Negative 1, 1. Negative 5, 5. Negative 3, 3. So do you see how that works? You plug in a negative x. It's the opposite of x. Does that make sense, everybody? Now, if you take the function and you flip it over the x-axis, it's the opposite of f of x. So your x values stay the same. So it's still at x is equal to 1. It's just your y values are opposite. So if this is over 1 up 1, this is over 1 down 1. If this is at over 5 up 1, this is over 5 down 1. So the negative goes in front of the function. Because think about it, f of x is our y values, right? Everybody? F of x means y, right? Does everybody see? So it's just switching the whole function. Alright. So, for this first example, it says, let g of x be the reflection of f of x is equal to 3x plus 3 in the y-axis. So we're taking this function and we're flipping it over the y-axis. It says, what's the function rule for g of x? Meaning, what's the equation for g of x? So you can find that. Well, you have to know, okay, so a reflection over the y-axis, you have to know is f of, oh, crapola. Did I say that backwards? Crapola. I did say that backwards. So reflection on the y-axis. Oh no, I just wrote, sorry. Reflection on the y-axis is f of negative x, which is what I did. Okay. Just making sure I didn't say something wrong.
So you said it wrong there.
What am I missing here? Just, okay. Sorry, I did, this is right here. So reflection on the y-axis is f of negative x. So we plug in negative x wherever there's an x. So we could go through and do this. So 3 times x, so we're plugging in 3 times x, but instead of x, we're substituting in negative x. So 3 times negative x plus 3 is negative 3x plus 3. So that would literally take that line and it would flip it over the y-axis. So it's a reflection on the y-axis. So what if I said I want a reflection over the x-axis? We would do negative of f of x. So we would put a negative in front of the whole function. So negative 3x plus 3. So then we could distribute that through if we wanted, and that would be negative 3x minus 3. Is everybody good with that? So that's just something you'll have in your notes, kind of memorize it. A reflection over the y-axis is f of negative x, and a reflection on the x-axis is negative f of x. Okay, so also we can take our parabola and we can stretch it or we can compress it. So it's either skinny or chubby. We can change that on our quadratics as well. So guys, if a is greater than 1, I didn't say this, sorry. A is always in front of f of x. So a is what's being multiplied to your function. So once again, a is what's being multiplied to f of x. So if we have, for example, 2 times x squared, 2 is being multiplied to x squared, right? That's either going to stretch or compress. So everybody understands something. If a is greater than 1, it's going to stretch it. And the stretch is on the vertical. So it would take our parabola and it would stretch it up. Does that make sense? If a is greater than 1, it takes your parabola and stretches it up. If a is less than 1, so like fractions, if you have a fraction that's, but there are fractions that are greater than 1, so be careful, right? Because like 3/2 is 1.5. So if a is less than 1, a fraction less than 1, it's going to take your parabola and squish it out. It's going to compress it. So a stretch and a compression. So once again, if a is greater than 1, it's a stretch, and if a is less than 1, it's a compression. So if I have 1/2 x squared, that stretches out your parabola. Okay, so it says, write an equation for each transformation, y equals x. So it says, by a vertical stretch of a factor of 4. So we know stretch and compressions are what's being multiplied to your function in front. So we're going to have y is equal to 4x. It's that easy. Isn't 4 being multiplied to x? So that's a stretch. And then a vertical compression. So once again, isn't this a value greater than 1? So that's why it's a stretch. And a vertical compression by a factor of 1/4. So we'll take that function, y equals x, and we're going to multiply it by 1/4. Once again, the reason it's a compression is because our a value is less than 1. Is everybody comfortable with that? It's pretty straightforward. Okay, so this is probably the hardest one for people to see. I'm doing last 2 examples, and I'm just going to let you work the rest of the time. Stay with me for these last 2 because they're the hardest for people to see. So it says, what transformations change the graph f of x to the graph g of x? So remember, we can have a stretch and compress, we can shift it up and down, we can do a vertical flip over the we can flip it over the y-axis or flip it over the x-axis. So we're going from f of x, how did we get to g of x?
So it brings it down 1.
Okay, good. So she was able to see, isn't it shifted? It was 2x squared to begin with, everybody, right? Well, it's definitely being shifted down 1, right? Okay, so I'm going to write that right now. You're right. Very good. Way to see that. We're definitely shifting our function down 1. You're on the right track. So remember that we can stretch or compress something by multiplying that front number by something, right? So we're saying, okay, so we started at 2x squared, right? So we started with a 2. 2 times what equals 6? 3. So 2 times 3 equals 6. Let's see, so you could have just divided both sides by 2, right?
Yep.
So we get 3. So does everybody understand that we multiplied this front thing by 3? Are we all good with that? So is that a stretch or a compress? Is it greater than 1? Yes, so that's a stretch. So it was down 1 and a stretch of 3. So does everybody see how to do that? So what's being multiplied in front is, what's being multiplied in front is a stretch or compression, and then anything added on the outside is your shift up and down, and then if there was something added with your x, that's your shift left and right. So what about this one? A little bit harder. So it says, what's the transformation of f of x that produces g of x? So we started with f of x is equal to 2x, and then we have g of x is equal to negative 3 times 2x minus 4. So first of all, the easiest is to shift up and down. What's my shift up and down? Down 4.
So wait, you want to go up?
Already up 12.
It'd be up because it's connected to
No.
so it would be opposite.
Wouldn't you just put the negative 3 in the wrong way?
It's,
Yeah, wouldn't it be left in the direction that's away from your x?
I see what you're saying. I'm trying to think of how to explain it. In this one, it's
This is,
not, it is down 4, but I'm trying to think of how to explain why.
Is it because the 3 is negative?
Everybody look up here. Because look right here. This is 2x, right? If it was being shifted with x, it would be connected into your x. Does that make sense? These parentheses are what's throwing you off. But it's just saying this negative 3 is being multiplied to the whole function. Does that make sense, everybody? So if we had the parentheses and it said x minus 4 in parentheses with x alone, that's when it would be shift left and right. Does that make sense? So now I'm processing it. Sorry, it took me a minute. Okay, so we're shifting our function down 4. And then we're multiplying by something to get to, well, we're multiplying, this is pretty straightforward. We're multiplying by 3, right? But what about that negative? That negative actually takes it and flips it over the, so remember, you have a negative in front of f of x, is that a flip? So do you guys see how there's a negative in front of our function?
Yeah.
Okay, so is that a flip over, a reflection over the x or y axis? Right. So this is a reflection over the x-axis. And we multiplied, and it's a stretch or compression of 3.
Compression. It's less than 1.
Right, less than 1, so that's a stretch,
I
right?
thought it was over.
Greater than 1's a stretch. Isn't 3 greater than 1?
Yeah, but it's negative.
It's negative.
No, the negative just flips it. The negative isn't counted.
Oh.
Sorry, that's why these ones are so hard.
Well,
Sorry. So the negative flipped it. You can't consider the negative. That's what's flipping. Does that make sense?
Okay.
So you can't consider that in the thing at that. You always look at the absolute value of that. So 3 is greater than 1, so it's a stretch of 3. Is everybody good with that? So negative in front, we'll flip it over the x-axis. Okay, so now finish the back page. So really, these are all the rules if you want them, if you want to take a picture of it. These are all the rules for transformations.
Why wouldn't you put the negative